morning. My name is Cheon from IBM. I'm based in New York. I'm currently CTO for Financial Services, and this discussion or presentation will be shared between myself and Sri, who's my colleague. He's a CTO for our payment center here in Canada, and we'll go through what that means and what we are doing here. Anyway, thank you for joining us this morning, early morning. And it's the first time for me in the Payments Canada, and it's been a great just to see the level of interest and excitement in the whole payment space. I was actually surprised how wide and the large the scope as well as the audience is. So it's been great being here yesterday as well. What we wanted to discuss a little bit is about payment modernization, but especially with respect to how cloud as a technology and a platform is going to be helpful, or the clients will be using cloud in their payment modernization initiatives. So before I do that, I wanted to just flash this and spend a minute on this one. When we look at a number of different technologies that are impacting or that are important for the transforming our industry, there are a whole bunch, and many of them, as you can see, have really been created in the last five years or so, or perhaps even more recent. And whether it's usage of AI in the banking industry, whether it's in fraud, in the process automation, or AML, or in the compliance and regulatory issues, whether it's around security, or perhaps even looking at a completely new way of computing, such as quantum, that we are exploring very actively. And yesterday, there was quite a bit of discussion about banking as a platform as well. And blockchain, I won't mention, given all the conversation we had about blockchain yesterday. But today, what I wanted to spend, what Sri and I wanted to spend a little bit is on cloud as a technology platform. And I would be happy to discuss about any of the technology that's on this slide at another time, but we won't have a lot of time to do that this morning. So we'll focus on what we are considering to be enterprise-grade or hybrid cloud that become the basis or underlying technology for the industry transformation. So it's no secret, cloud is accelerating digital transformation. But it's interesting that it's not too long ago when I would have a similar presentation like this with some of the clients, and the banking clients. In fact, it's only probably about 4 years ago with one major bank, one global bank. And they said, OK, can you skip the cloud because I'm not interested in that one. Let's focus on the other aspects. But that's clearly has changed over the last few years. And it is clearly a platform that is used to innovate with the latest technologies from a lot of different sources. And that's what many of the clients and many of you are doing this. And it also gives you access to a lot more, and especially external data sources that you can leverage as part of your platform to the analytics or other insight-related applications. And so clearly, clients are getting ROI from investments in the cloud. But when we look at what has been done over the last few years, especially in the banking industry, a lot of it has been, in some sense, relatively easy stuff, I would say. It's lifting and shifting some of the applications that are probably not mission critical, or building some new applications that are cloud native, and that's all good. And these are all good things, and we are getting good advantage in terms, especially with respect to time to market or giving more flexibility, as well as getting return on investment. As an example, we were doing a project with one of the large global banks in Europe, especially on their PSD2 initiatives, because they wanted to use PSD2 as a way of doing request to pay. And this is a client that, for that area, in the payment area, has never used cloud. In fact, the IT organization did not want to use cloud. But the business said, we have to use cloud, because otherwise it'll take me 6 months to even just procure all the systems that are necessary. Whereas we need to go launch this in the next 6 months, or within 6 months. So building new cloud-native application as a way of innovation, and as a way of launching new capability or new products or new services, that's where it clearly has been, cloud as a technology platform has provided great benefit. But where we need to go next is really now looking at some mission-critical applications, whether it's a core banking systems that are deeply transactional as well as that are deeply critical for our industry, and the payment systems. And this is where the payment modernization becomes an important area for us to be able to tackle as we look at modernizing and potentially looking at cloud as a technology platform. So what's preventing modernization? And in some sense, it's probably an obvious thing for this audience. There are unique workloads that we have to be extremely careful for regulatory reasons, for transactional reasons, performance, latency, and data residency reasons. So certain workloads cannot be moved easily, especially to a public cloud. But there are also, and this was discussed quite a bit yesterday in one of the sessions with 5 major banks in Canada, as they are looking at payment modernization and lack of skills. In order for us to modernize payment systems, the skills you need, the Venn diagram of the skills you need, which is the understanding of payment system, understanding of the legacy, understanding of the cloud native technology, is probably pretty small. And so that is going to be a really important area for us to continue to strengthen and grow the skills in that space. And in fact, when we look at all of the clients as well as the industry data, probably less than 5% of the workload or typical banking workload have moved to the cloud. Because as I mentioned in the previous slide, most of the movement have been on some of the easier things. So when we look at the journey, we do believe that the hybrid cloud or hybrid and multi-cloud is actually the destination. It's not just a transition into a public cloud. When we look at how the landscape, IT landscape will change, clearly traditional IT is going to get smaller. It will get smaller, and we see that probably over the next 3-4 years, it will go down by about negative 9% per annual. And the growth will be both in the public clouds, but also in the private clouds, to the tune of about $1 trillion+. We did a recent survey together with the Boston Consulting Group and McKinsey with about 100+ clients around the world. And what they've told us is that a large majority, 94% of them, are already using multiple clouds. That's including multiple public clouds, obviously multiple SaaS services, as well as private clouds on their own premises. And that provides or presents different type of challenges. One, how do you manage your environment across these different cloud environments? Some of them may be coming from IBM, some maybe from Azure, from Amazon, as well as your on-premises capability. And how do you integrate and ensure that there is a security across all of these different cloud platforms? And those are the areas right now we have been focusing on trying to address. So when we are modernizing applications, because of the fact that we will be using multiple clouds, we want to be able to modernize once and be able to run it everywhere. And this is why the open source is critically important in how we leverage the open source, but also the technology called containers and Kubernetes to manage multiple containers. That's an important aspect. And this is one of the reasons why we are in the process of acquiring Red Hat as a company, spending fairly significant amount of cash to do so, because we do believe that open source is going to be critical for our largest clients, not just for the startups. So when we do have multiple clouds and workloads running in multiple different environments, one of the critical capabilities that we need to have is to have a control plane where you can have visibility across all of these different cloud environments, and also be able to move workloads where needed seamlessly without having to do major amount of system integration work, and also being able to ensure security. And that's one of the reasons why we have, especially to be able to address the workload requirements for our banking industry, we have what's called HyperProtect, where we can do key management, essentially using our mainframe type of capability on the cloud to manage all your enterprise keys. Also be able to manage the keys on-prem, but be able to use those keys on your public cloud as well. So if I look at just what I mentioned in the last few minutes, these would be the key 5 principles that we believe are important for our banking industry, especially as we modernize payments infrastructure, and as well as perhaps for some of you, core banking infrastructure. Hybrid cloud, knowing that what workloads should go where, whether it's on-prem, public, or virtual private, that is dedicated public clouds. Being able to manage multiple clouds, and knowing that and capabilities and characteristics of different clouds, and be able to place the right applications or workload. Leveraging open technology so that you're not getting locked into one technology vendors, even if it may be from IBM. And making sure there's a security across all of these platforms. And then being able to manage across all of these different heterogeneous environments. So with that, I'm going to invite Sri to come up to talk about now, what does this mean for payments, especially in payments in Canada.
Thanks, Jay. Hello, everyone. Good morning. Sri Narayanan. I'm the Chief Architect for IBM Payment Center for Canada, and also I'm part of the FSS CTO office that Jay leads within our IBM Global Markets team. So what I'm going to do is bring home some of the messages that Jay provided into payments. Specifically, what does this mean from payments workloads perspective? How do we look at this cloud journey from payments perspective? So that's what I'm going to be focusing on. I think people are generally sold on the value proposition of cloud. It's all around agility. It's around cost economics. It's around efficiency. It's around ability to harness innovation, et cetera, et cetera. However, what we've seen globally with our banking clients, especially our large banking clients, when it comes to core bank workloads, or more specifically payments workloads, they tend to be very conservative, and rightly so. And the reason for that is because you've got a mother load of regulations that govern the whole aspect of storing and moving money, and rightly so. And then on the other hand, you have the tension of how do you drive agility, given that you've got your technology infrastructure that is obsolete. You've got regulatory-driven modernization initiatives, like what's happening here in Canada. And then, of course, you've got market challenges, which is from your fintechs and whatnot. So you've got this tension on both sides, which is regulatory compliance, risk management and governance on one hand, and on the other, how do you do it in a way that you can leverage those cloud qualities of service? Is there a middle ground? And we believe there is, and that's the approach that I'm going to be talking about. So first, let me go through a little bit of risk and compliance issues. I'm not going to go through the alphabet soup of regulations that we have here in Canada. I'll just name a few. Obviously, Bank of Canada as the regulator for the large value and the low value systems as per the Payments Clearing Settlement Act, and then Payments Canada as an operator of the systems as per the Canadian Payments Act, have laid down rules and bylaws. And all federally regulated financial institutions, especially those that are direct participants, direct clearers, have to abide by them. So that's the first one. Secondly, this is actually a really nice diagram to kind of keep in the back of the head. This was published as part of the Retail Payment Systems Oversight Framework that just actually came out this year. It was released as part of the Canadian budget, and it's actually going to become into a law at some point. But this really gives you a good way to think about the balance of safety and soundness, efficiency, and user protection. So if you see on the, I guess the far left for me, you have the large value transfer system, which is systemically important. Well, systemically important means Bank of Canada has a specific set of risk management standards, which obviously come down from BIS, but have been, in some sense, I would say, repurposed for Canada by Bank of Canada. And these principles of financial market infrastructure risk management standards really dictate how you manage, measure, monitor risks within your large value transfer system. And this just holds not just for Payments Canada as the operator for LVTS, but also for the banks in terms of how they approach their large value transfer systems or their wire payment systems. And what does this mean? Actually, if you look at PFMI, it places a pretty high bar in terms of how you manage operational resiliency, security, and things like settlement finality, the need to have a business continuity plan to ensure that you have settlement finality by the end of the day. And so That applies not only to the large value transfer system that's operated Payments Canada, as I mentioned earlier. A lot of those risk management standards need to be imbibed in some shape or form by the financial institutions who are operating the wire payment systems on their end. And more importantly, these are being extended to the payment service providers as part of this retail payment system oversight framework. Again, the degree of risk changes. Obviously, if you are a retail payment system provider versus a low value versus high value, but the principles largely remain the same in terms of how you manage, mitigate operational risk, how do you ensure end-to-end cyber resiliency, and so on. So that's a pretty important standard that dictates from an operational standard and the way you manage your operational risk from the perspective of availability, cyber resiliency, and whatnot. The second one that is an important one to highlight is OSFI as well. So OSFI has published what they call as B10, which is really the standard or guidance they publish for federally regulated institutions that are using third-party outsourcing providers for offering IT services, as an example. And in the case of OSFI, the B10 basically has stipulations or guidance around things like data residency, data protection, and then, of course, ensuring encryption of data in transit, at rest, and, of course, access and audit rights. Then we've got FinTrack. FinTrack is mandated as per the Proceeds of Crime and Anti-Terrorism Financing Act to ensure that there's no money laundering, that there's terrorism financing. Basically, FinTrack's mandate is to detect money laundering and terrorism financing activities. And banks have an obligation, therefore, to actually comply to regulations such as FinTrack. So that's kind of a broad stroke. Of course, from a consumer protection standpoint, you have standards like PIPEDA, which are quite relevant to apply here in Canada. So when banks or financial institutions think about payments modernization, think about where their workload's going to go, the first question is it going to go in Canada? And if so, well, does the cloud provider can they actually meet these standards in terms of operational resiliency, scalability, availability, data security, et cetera? But then, you think about US and a lot of, a lot of these factors kind of complicate more in the sense that you don't have flexibility to use a cloud provider if it turns out that they have, their main data centers out in the US. So these are some of the key aspects why banks have taken a very cautious view. And as I said, rightly so. However, I think there's also some other key drivers which are making them look at cloud from the standpoint of, as I said, where can they take advantage of the cloud? So yes, you need to ensure, that you've got a sound framework for risk management and you're complying with regulations, but what are the opportunities for me to leverage the cloud qualities of service? And this is where the technology and market challenges come in. Payments modernization in Canada has been a great driver for banks to essentially look in the mirror and say, hey, where are we at? And in terms of being able to modernize our large value, low value, and eventually move as well to real-time rail. And what we've seen pervasively across the banks is the challenge from moving from batch-oriented systems, most of the systems are batch, to more of a real-time, always-on type of systems with fully automated operations. And why is this a challenge? Well, it's a challenge not just because of the fact that much of the processing, the back office processing is batch. It's also because we're dealing with siloed, redundant systems as well. So these systems have organically grown over the years, and it's not easy to change these systems. And again, delivery cycles, release cycles for these systems tend to be awfully long and expensive. In addition to that, there are manual operational processes. There's a lack of unified view of data. So all that to say is that you've got, on the one hand, you've got regulatory compliance issues. On the other hand, you've got market challenges, which is, shrinking margins, consumer demand expectations, fintech competition. Then you figure, oh my God, how am I going to deal with this? Then you realize, by the way, my IT infrastructure sucks. It's not ready. I can't modernize. So this, I think, is a perfect storm in my view. And actually, it's also a perfect opportunity because what better driver than a payments modernization, kind of like a hammer coming down you to actually take a look in the mirror and say, okay, what do I do better? What can I do better? And I think our point of view here is that there's certainly a middle ground. There's certainly a way for you to leverage cloud qualities of service and think about your architecture for payments modernization in a way that positions you well on the journey. It positions you well in the sense we believe there's a place to start that will position you really well for where you want to be in future. and in a way that actually allows you to take advantage of the benefits cloud offers without sacrificing on some of the things that we discussed. So let me go through some of the key architecture principles that we see. And this is this is not just an IBM point of view, by the way. In terms of these architecture principles, we didn't actually discover them or invent them. A lot of this, quite frankly, came out of the lessons on the ground. We talked to our clients. We helped them with that modernization across the globe. And in that process, we've codified a set of principles that we see works for core banking workloads or for payment workloads. So start with hybrid multi-cloud deployment. In our view, you're not going to put your core payment workloads on a public cloud, period. You're going to put them in, likely, a private cloud on-prem, and as a next step, private cloud off-prem. So you're likely going to put them on public cloud, but they're not public in the sense that living in a multi-tenant infrastructure from a compute storage standpoint. You're likely going to ring-fence them, put them on a private cloud within public cloud so that you can leverage some of those qualities of service, things like elastic capacity, provisioning on demand, and whatnot. You can get the cost and time efficiencies and agility without actually taking a whole lot of risk. So we see certainly this journey looking like workloads living on-prem on your private clouds, but then essentially the private cloud architecture is architected in such a way that it also lives on a public cloud and potentially multiple public clouds. And what you end up with is this hybrid multi-cloud model, and when architected right, it gives you the ability to have workload mobility across the cloud. You can transition your workload where it makes the most sense, whether it's from the standpoint of cost efficiencies, whether it's in standpoint of the qualities of service you're getting, the type of services you're leveraging, and whatnot. And so certainly thinking about this as a hybrid multi-cloud model is, I think, a good place to start. Operational resiliency, again, starting with a topology or a deployment model that gives you that operational resiliency, in the sense that you start off by looking at this as a multi-data center topology. In fact, I think I'd give an example of Westpac here, one of our flagship clients that actually done exactly this. They have a private cloud on-prem. They have a private cloud off-prem. And by the way, Lloyd's has done basically a very similar architecture as well. And one of the things they asked for when they designed this, we need the off-prem private cloud to be active-active. And that was a gap that we had about 2 years ago. But now we've got metropolitan data centers in both London and in Sydney, whereby we can actually provide full active-active support for workloads as they seamlessly transition from on-prem to off-prem, either by choice, because you decided I'm going to move it because of all the reasons I mentioned earlier, or you have specific use cases where you're bursting workloads to the cloud, or you need to move workloads for doing things like patching, upgrading, or whatnot. On your on-prem, you can do vMotion, you can move your workloads off-prem, and you can do those things and then move them back. So it gives that flexibility. But when you need that flexibility, you want to make sure that the off-prem private cloud provides you with the same qualities of service. So designing that upfront and demanding that of your cloud providers is quite critical from a resiliency standpoint. The second point I want to highlight is as well software-defined data center architecture. I mean, this is almost motherhood now, right? In the sense that you want to make sure that as you look at your data center architecture, from your infrastructure up to your platform to up to your applications, it needs to be fully software defined, which means all aspects of the data center are essentially controlled, managed through software control plane. VMware Virtualization is a great example where VMware provides you with this ability to manage completely through software provisioning of storage, provisioning of compute nodes, configuration of your NSX network and NSX firewalls and whatnot. And why is this good? This is good because if I can turn all of that data center configuration or management into software, drives automation. I can now automate it through not only my DevOps cycle, but I have the ability to automate it from a steady state management perspective. The third is security, risk, and compliance. I mean, I think this was very well summed up yesterday by Bruce Schreiner when he talked about three things. Actually, it's three things that I think pretty much sums up the kind of security architecture you need to put in place. He talked about the CIA, which is confidentiality, in the sense that only authorized users can access the data or systems. The second is integrity. When they do access the data, nothing has changed or been tampered with. And the last one is availability. And so actually, I think this is something people don't actually think about a lot, because often you talk to developers or infrastructure architects. When we talk availability, it boils down to fault-tolerant systems. Oh, I can just throw in a couple of clones of this node and I'm done. The reality, it's not. It's just availability at the infrastructure level, but your availability could be compromised because of security threats, in the sense that if somebody drops a malware onto that server, you're toast. So if that endpoint is tampered with, you're toast. And you can have a denial of service attack. If you don't have security baked into your network infrastructure all the way from perimeter up to your protected zone where your systems or your data live, you're toast. So to me, the security and availability kind of go hand in hand. And again, here, you don't have to reinvent the wheel. The good news is that we have standards such as the CPSS IOSCO, which is actually a standard from BIS again, that actually gives you a cyber resiliency framework. It's a NIST-based framework that talks about how do you identify, detect, prevent, respond to security incidents, security threats, and how do you bake into that an ongoing security testing process overall with security governance. So there are very well-defined security best practices from NIST and CPSS ISO that should technically get baked into your solution. And when I say baked in, that is across all layers of the solution, right? Starting from your infrastructure layer, how you secure your compute storage network, to the higher layer, moving into identity access management. Again, not from a single data perspective now, looking at identity access management from a hybrid multi-cloud perspective, because you have now, with flexibility, multiple attack vectors, because you've got your private cloud off-prem and a private cloud on-prem. So really looking at those security threat vectors across the board, and essentially looking at how you can have a more holistic security posture. So with that, let me go to the next point, which is open standards. Again, the way we see the approach to hybrid multi-cloud architecture is through open standards. And that is across the board from your IaaS layer or PaaS layer or your container as a service layer and whatnot. And I think Che mentioned earlier, containerization, orchestration technologies we see as being pretty fundamental to the hybrid cloud journey. Everybody started the cloud journey with virtualization. It gets you so far. You virtualized your hardware. You can obviously do a lot of the automated provisioning of infrastructure components. But that alone is not enough, because the next level of virtualization or abstraction is going to be at the operating system level. Can I package an application with all of its dependencies into a container? Then the container becomes a unit of development, a unit of deployment, a unit of management. Right? And so that's basically what we are seeing as the next level evolution. And the notion of software-defined architecture just moves one level up. When people typically talked about software-defined architecture, they were always talking in the past, at least 4 or 5 years ago, in the form of virtualization, which is what things like OpenStack and VMware VCS type of infrastructures provide. But now when we talk about software-defined architecture, we're talking about a higher level of granularity at the level of containers. And you have technologies like Kubernetes, which can completely abstract away the underlying infrastructure for you. And it can do everything from container deployment, management, failover, resiliency, load balancing, all that stuff get abstracted into a container orchestration layer. Moving on, I think analytics first. Again, it does needless to say, I think when we talk about analytics, often we've seen the approach of an afterthought, right? Design system first, and then we'll figure out what to do with the data. No, it's going to have to be baked in from the very beginning. And then finally, transparency. I think this has been sort of a nagging problem in many banks, in the sense that you don't know where your payment is at. And it's worse, not only within the bank, when you leave the bank, again, you don't know where your payment is at. And some of those problems are being solved by things like Swift GPII from a cross-border payments perspective. But obviously, within financial institutions, because of the evolution of technology stacks over time, unfortunately, analytics is a little bit of an afterthought. You have these siloed payment engines that process payments, and then you kind of get the data in the back end. You try to analyze it. It's difficult. It's really difficult, and we all, I don't have to name the enterprise data hub or enterprise data warehouse projects that have gone wrong. So the reality is, I think we need to approach analytics almost from day one. It has to be baked into the design. And what that means is more of a event-oriented, stream-based analytics. As you're doing inline transaction processing, you're essentially streaming data to your analytics system for doing things like real-time generation of real-time insights, predictive analytics, and those type of things, because you have far better data currency. So again, this is how we see as a bit of I would call it a reference model for the architecture, almost a 30,000-foot view in terms of how we see you need to approach this. And I'll get into another slide which gets into a little bit more detail. But if you look at this, again, the vision we are talking about here is, as you approach this, your private cloud architecture, on-prem, off-prem, you need to design it in a way that you can support multiple delivery models. And that means, deploying it to the vendor of your choice. Like I should be able to take my private cloud and go where I want to go, whether it's IBM or GCP or AWS or whatnot. What you want to avoid is vendor lock-in. And that's becoming a big challenge now because partly it's the evolution of cloud. Obviously, AWS had a bit of a jump start, but we all know that one of the issues with AWS is obviously the lock-in. But now many clients are going to Kubernetes-based services, whether it's on our cloud with something like IBM Kubernetes Service or ICP, or with Google like GKE, Google Kubernetes Engine, or Amazon has their own EKS, I think Elastic Kubernetes Service. So bottom line is I think that trend we are already seeing where clients are saying, my choice, my workload, my choice in terms of how I want to build it, again, standards-based, and I want to be able to have that mobility so I don't have a vendor lock-in. And of course, we know that investing in open source technologies has traditionally proven to provide a better TCO over the long term, simply because of A, skill sets, B, the wide variety of choice you have available from time to time running those platforms and whatnot. And of course, you don't have to go open source by downloading a product off of the internet. You have now supported open source products. Red Hat is obviously the biggest provider of a lot of these supported products. And then as you move up, right, you've got multiple delivery models. As you move up, we talked about open standards. I'll just mention a few here. I don't want to go into too much details. Obviously, I think the two technologies that we think are really foundational from the standpoint of building this private cloud are containers and container orchestration. With containers, again, Containerd is the open source runtime from Open Container Initiative. And obviously, Docker supports that. So we typically see clients actually standardizing on Docker as a container technology and Kubernetes as the orchestration engine. And then as we look at building microservices, again, microservices, the beauty of microservices is it takes the idea of containers to another extreme as well, in the sense that while containers are a nice way to package your business capability or your functionality or your applications, microservices are all about how do you break that package into more granular elements that allow you to scale independently, deploy independently. So to me, it is taking that notion of containers to another extreme where we are saying, well, we don't want to deal with a monolithic application package in containers. I'm still going to have the same problems around how do I manage these application releases? Because it's one big application that I package into containers, I want to break those application releases down to give me more flexibility. And that's where microservices come in, and the technologies we are seeing there are standards we are seeing there, and ones that we are deploying in many clients are essentially technologies like Istio from a service mesh standpoint. So your microservices can be polyglot. You can build them in any language you like, but you need one way to manage them. Load balance requests between them, handles things like failures, logging, tracing, etc. So Istio is certainly a key technology that we are looking at, and as well many of our clients are deploying from a private cloud standpoint. And then moving up the stack from a cloud operating environment perspective, again, standardizing on your cloud services. And in this case, I think you'll be looking at a variety of services, whether it's your integration-related services from, let's say, message queuing type of capabilities, or your application servers and whatnot. And the idea, again, here is you want to go for containerized, in some sense, containerized packages for these middleware components, because it'll allow you to manage those containers, again, from the orchestration engine such as Kubernetes. So to me, I think those are sort of some foundational elements. Let's look at what a reference architecture might look like. And again, this is a reference architecture. It's not, I don't want to say that this is prescriptive, but this kind of illustrates what the reference architecture will look like, right? So from a private cloud deployment, what is shown here is we've got a private cloud deployment on-prem. We've got VMware software-defined data center architecture as the IaaS layer, the infrastructure as a service layer. Again, VMware is an industry standard pretty much around virtualization. But if you want to go for something more open, you can also go for OpenStack. And then layering on top of the IaaS is your container as a service layer. And the two core technologies I mentioned there are Docker and Kubernetes. Docker as a means for containerization and container deployment. Kubernetes as a means for managing those containers and really abstracting away a lot of the concerns around management, high availability, resiliency, and whatnot. And then you have your PaaS layer that kind of sits on top of that. We are seeing a bit of a merging of the PaaS and the CaaS, I would say, in the sense that traditionally as PaaS evolved, right, we started having things like Cloud Foundry runtimes, we started having cloud vendors that would provide you a fully managed application server or a messaging server or whatnot. But what we are seeing now is a convergence where a lot of these platforms are also being containerized. And so you now have container versions of these available. So even for us, we ship our container versions of everything from DB2 to MQ to WAS, Liberty, and whatnot. And you've got the ability, therefore, to manage them as containers, right? And so I am seeing that the two are sort of merging, and then your payment workloads kind of sit on top of that. Now, I talked about hybrid multi-cloud, and so on the far left, you see that we have a private cloud deployment on public cloud, and this is for, in this example, for your lower environments. So your lower environments, like your dev test, can sit on the public cloud, again, within a private cloud on public cloud, and you can leverage those cloud qualities of service. What are they? Well, in the case of dev test environments, there are some really good use cases you can think about, right? Ability to provision your test environments on demand. When you drive test automation through DevOps, one of the things you want is I want to be able to spin up, 80 or 100 environments, run all my automated tests, and tear them down. And I'm only paying for what I use. So that's a benefit you would get from actually putting your lower environments on the cloud, but keeping your higher environments, again, under the security of your data center. And there are other use cases as well for the kind of stuff that can go on a public cloud. And then, of course, this also shows that you've got your third-party workloads on the public cloud as well. Well, as you think about this architecture now, you've traded off. Architecture is all about trade-offs, right? You've traded off, a set of benefits for a set of, potentially things that get complicated. So in this case, the benefits obviously is that, I'm putting the right workload in the right cloud, and I'm achieving that economies of scale and the agility and the efficiency. But what am I giving up, or what's the trade-off for me? Well, there is no free lunch. And I think in this case, the issue is certainly you need to have a really well-oiled DevOps machinery that can deploy workload where it needs to go. You need to have orchestration of your workloads. Like, how are you going to manage your container workloads across all these clouds? You need to have some way of deciding dynamically through something like Kubernetes how you manage the cluster lifecycle. I've got a cluster running here, I've got a cluster running there, and I want to move workloads between these clusters. So how do you manage your cluster availability, cluster orchestration across multiple clouds? How do you do monitoring? Again, you have to make some foundational architecture decisions around monitoring. You've got now workloads spread across multiple clouds. And from a monitoring perspective, again, we have a point of view. Typically, we see technologies, open source technologies like Prometheus and Grafana playing a big role when it comes to monitoring of workloads across multiple clouds. Prometheus is basically a technology that allows you to essentially collect monitoring events, and Grafana provides you with a visualization dashboard. However, these are really technologies that are more geared for containerized workloads, and you are going to have a mix for a while. You'll have some container workloads, you'll have some traditional workloads that run on bare metal or on virtualized servers. So you will need a much more comprehensive monitoring tools on top of this. So besides Prometheus Grafana, you're going to need a monitoring tool that can actually do that end-to-end monitoring and provide you visibility and alerts, event correlation, and then, of course, linking in to service management. So that's something not to lose sight of, because it does this architecture will require you to make some deliberate decisions around how you do end-to-end integrated monitoring. Then, of course, comes security. Everything from we've talked about earlier, which is at the infrastructure level, having the security at the infrastructure level, then moving up application security. How do I do identity access management across all of these clouds? How do I do endpoint detection, endpoint response across all these clouds? And the key here is that what you want to avoid is going after point technologies that each of the cloud vendor offers. I think you need to look at this more holistically, because you want the visibility, you want the control and governance. I don't want to throw technologies out there, but there are technologies that we are working with that can provide you with that integrated dashboard. Take SIEM as an example, security intelligence event monitoring. I've got these clouds that are running in multiple places. It's on-prem, it's on multiple public cloud vendors. How do I receive security event logs and detect security threats? So we have a solution called QRadar, which can actually do that. It can collect event logs from multiple multiple destinations, and can do log correlation, log aggregation, and essentially provide you with security intelligence and threat monitoring. So I think it's important not to lose sight of some of these critical aspects, which is the first step is obviously where the workload goes, what's the right cloud for the right workload, so to say. But then more importantly, as part of this architecture, which is not elaborated on this slide, is to actually look at what your integrated monitoring, integrated security approach going to look like, and of course, how are you going to actually do DevOps across these multi-workload deployment. So next I would move into sort of the payments reference model. The purpose of this reference model is to really motivate a discussion around, when it comes to payments, how do we make a decision? We've got a set of capabilities. Is there a roadmap to make a decision on what's going to be on-prem versus what will be off-prem? Again, as I said, if you put the lens of risk and compliance and the need for agility and responsiveness and whatnot, I think there are certain calls you can make. I mean, we have a point of view, and obviously it'll be subject to debate. But that said, I think the goal here is to say, well, let's look at what are those big picture capabilities we typically have within payment systems, and how do we approach modernization of this, or how do we approach, let's call it a cloud modernization for such workloads. So what this diagram shows at a pretty high level here is that within your payments architecture or landscape, you've got a set of gateway services, which are your channel applications. You've got your API, message gateway, file gateway. They're not going away anywhere, right? I mean, you're not processing fine API-based transactions. A lot of your core payment transactions today, if you are ACH, is file-based, often a message-based as well. And then, of course, you have your more modern API type of services. And then what you have is a set of shared payment services. These shared payment services are services that are shared across payment types. So if you look at the center of the diagram, right, you have your core payment engines, which are your wires and your ACHs and your check processing engine and whatnot. These offer clearing, exchange, and settlement services. But then these core payment engines often are leveraging a set of shared services. And there are examples of that here: payment initiation, message transformation, things like preliminary validation, enrichment, authorization, entitlement. I mean, often you have entitlement systems within bank where you're, for example, validating whether a customer is actually entitled for a particular product. You have your pre-fund checks, limit checks, and whatnot. So as you look at these shared services, some are actually very tightly coupled to your core bank systems. It's hard to take them and put them on the off-prem, so to say, because if you're not moving your core banking workloads off-prem, then you're not moving a lot of these services off-prem. They're going to have to live on-prem. But what you could do is look at how you design those services going forward. Again, they could be designed with a more modern containerized-based approach, API microservices-based approach. There are certain services, though, that technically could move, in this case, off-prem. So as an example, the channel applications we talked about, whether it's your mobile, online banking applications, because much of these applications are focusing on the payment initiation side. If you look at the value chain of payments, right, you've got payment initiation, you've got authorization, payment authorization, and transmission, and then you've got your actual clearing and settlement. Really, you have to look at the risk factor end to end, and in the case of initiation services, a lot of these are good candidates for you to actually throw them off-prem, because the workloads there tend to vary very significantly, in the sense that you have a mobile banking application, you see a peak in terms of how it gets access. It can actually leverage some of the elastic capacity that cloud can offer. So that's as far as shared services. Like I said, there's going to be some that will be good candidates to go off-prem. There is channel applications. Or core clearing and settlement engine, we see it as saying more on-prem. That's what we've been saying. We don't know of a client that's actually decided they're going to run this on a public cloud off-prem. But that said, this is where this is essentially like a crown jewel, right? This is where you're actually processing your wire payment end to end, or your ACH payment end to end, and whatnot. And then as you move down this diagram, it shows the transactional, operational, and reference data stores. Transactional data is often tied to the engine. Your data has to be obviously co-located or located close to the processing. That's kind of a best practice for latency, bandwidth issues. So typically they tend to stay on-prem, will tend to stay on-prem. However, analytics is certainly an area that you could move off-prem, because analytics is going to require obviously a fair amount of compute capacity. And you can certainly leverage, not only that, not only the compute capacity, but you can leverage some of the cloud services that are out there for doing things like predictive analytics and cognitive insights and whatnot. So certainly analytics is a workload that we are seeing as one that you could put off-prem. Risk and compliance perspective, again, you have your fraud screening, AML sanction screening, and regulatory compliance management systems. Certainly this is a good candidate as well for you to think about off-prem. We've actually had several clients that have asked for a SaaS type of offering around fraud and AML sanction screening, because it's very much pattern driven, number one. Number two, the data can be in some sense anonymized as well. And so you can certainly ensure that you're offloading this processing to a, let's call it a SaaS vendor, while at the same time ensuring protection of your data. So we certainly see that that's an area as well that could potentially go off-prem. So with that said, let me talk about sort of what the journey itself will look like and how you approach this. I think there's 4 parts to this, right? One is, as you look at payments modernization, start with architecture foundation. And we talked about that already. What are the guiding principles? What are the foundational technologies? So you need to make a choice in terms of how you design, deploy, package your application workloads, how you manage them, how you secure them end to end, right? So that's the first step, is establishing that foundation. And it's a choice, it's an architecture, it's a choice of set of technologies based on that architecture. Next is to analyze your payments portfolio and develop a workload strategy. And that's what I did in about 30 seconds in the last slide. And that's, to me, is a big picture. But obviously, you're going to have a payments reference model blown up. And you look at that and go, OK, this is my portfolio looking like. These are the set of capabilities. What my workload strategy going to be? The next step, and when I say workload strategy, really what I mean is strategy around how you're going to design, build. I would say it's a strategy around how you're going to design, build, source it. And secondly, where are you going to place it, right? And so, for example, here we talk about replatform, refactor, and repackage. You might say, well, it's going to take me forever to change my wire payment system. We know how many banks have tried doing that over the years. So we're just going to replatform this, and we're going to go for a package solution. Well, then the question still becomes, OK, in this case, our workload strategy is going to be, we're going to source the workload from a vendor. We're going to acquire a package. The question then becomes, well, is this package going to lock me into a particular architecture? So you need to challenge the vendor to ask, well, do you conform to this architecture? Are you going to be able to offer this to me, let's say, as a containerized application, perhaps broken down into micro or macro services, right? And something that I can then package, deploy with flexibility in the location of my choice, whether it's on-prem or off-prem or the cloud of my choice. And that's an important question to ask, because we don't want to go as part of modernization from one set of challenges you've had to another set of challenges. So that's as far as replatform. You may decide to refactor and repackage yourself, in which case, again, you have to look at how you approach it. So from a repackaging standpoint, to me, repackaging is really taking a first shot at breaking down the monolithic that you have, whether it's your wire system or ACH, into a set of modules that are containerizable and that can run in Kubernetes. And I can get some qualities of service that way. Refactor, to me, is taking to the next step, which is saying, well, I package them into more, in some sense, modules that have better granularity rather than this big monolithic that has this long release cycle. We all know how the release cycle for BEST, for example, typically 1 or 2 a year. And so now I have a much better way to drive my release cycles. But then I got to go to the next level where I want to break my modules into perhaps more micro and macro level services, independent units of capability that can be independently deployed, scaled, tested, managed, et cetera. So that's part of the whole repackage and refactor approach. And then, of course, the decision is, where does this go? Like, I've decided now I want to replatform this, and I mentioned the sourcing strategy earlier, repackage this or refactor this. Then the question becomes, where does this actually go? And that's where the decision is it going to go on-prem as a private cloud? Is it going to go off-prem? If it goes off-prem, then what am I leveraging off-prem? Am I leveraging just the IaaS layer or the PaaS layer? Am I leveraging the IaaS, PaaS, and CAS? Or is it going to be a SaaS? Like, again, fraud is a great example. I go through my fraud system currently, and I can say, well, you know what? I'm going to replatform this, but I'm just going to do this completely as a SaaS, right? So that's another example. And again, there's no one answer that I can give you today. But that reference model is where you want to start with. We've got some answers that we've typically seen with our clients, but the journey will look different, because every institution is unique, and the journey will look in some cases different. And then the last piece is, of course, once you've got these workloads, once you finalize the workload sourcing and placement, then it's about the actual workload deployment and operationalizing that workload. And part of that operationalizing is the ongoing management, the governance, and whatnot. And that requires a level of maturity within the organization, because managing a multi-cloud environment is very different from managing a traditional sort of data center type of environment. Because, like I said, it does increase dramatically the complexity, but at the same time, it also gives better visibility and control. Nevertheless, I think the point I'm trying to emphasize is that it is a bit of a learning curve for the operations team to basically operate in this new world. So this one, I'm going to go really zippy fast. I mean, basically, this is what we see as an evolution of how people are moving to the cloud, from virtualized to cloud-hosted, to cloud-ready, cloud-enabled, and cloud-native, right? And it takes time. So as you move your workloads, the first step is, of course, cloud-hosted, which is just lift and shift. You just run this stuff for me. I don't care about architecture. We'll deal with it later. The next step is cloud-ready, where you're saying, OK, well, now I'm interested in actually seeing how I can get a true IaaS platform, right, where I get capacity on demand, I get metered based on usage, and so on. So that is the cloud-ready, run in cloud. Then you get cloud-enabled, where you're saying, well, my workload just doesn't need servers, like virtual machines. Now I want to take advantage of some level of containerization, because I've got some DevOps maturity, and I want to take advantage of containerization and drive more agility. That's cloud-enabled. And fully, of course, the nirvana is when it's completely cloud-native, where it actually can take advantage of the native capabilities offered on the cloud, which to me is a combination of how you approach breaking down of your monolithics into microservices, macroservices, again, drive containerization, orchestration, drive that end-to-end monitoring across your clouds and whatnot. And lastly, leave some time here for questions. I think I got about 8 minutes. But this is really talking about the role of DevOps and the journey to cloud. It's almost like you can't have one without the other. So, in other words, the way I see it is, if you want to move to this vision of a multi-cloud architecture, there's no way to get there without actually having DevOps. Because what multi-cloud is simply going to give you is a set of tools. Yep, I'm going to give you a virtualized SDDC. I'm going to give you, Kubernetes. How do you take advantage of that? What's your pipeline going to be end-to-end for you to design, build your workload, deploy it, leverage the ability of cloud to spin up environments, whether it's container-based environments or virtualized environments, do your automated testing, tear them down. So you can't take advantage of the cloud in terms of those cost efficiencies and agility without having DevOps pipeline. Conversely, cloud is an enabler for DevOps too, because DevOps requires a set of tools. DevOps requires you to orchestrate a pipeline. DevOps requires the ability to provision and deprovision environments on demand. DevOps requires the ability to request capacity as needed based on the kind of workloads you're running. For example, if I'm deploying a test workload versus a production workload, I'm going to need different qualities of service. DevOps requires an integrated management of the entire infrastructure with security testing baked in. So all of those things, again, require you to have a cloud deployment model and a sort of a foundational cloud architecture. So the message is this. I mean, to summarize, the message is that, one, I think you can't be successful with payments modernization unless you have a cloud strategy and a cloud architecture that is hybrid multi-cloud. Yes, there is a way to design it in an open manner that doesn't get you into a vendor lock-in situation, and more importantly, provides you with better return on investment, better choice, better flexibility. And lastly, DevOps is a very integral component of this, and it's important for you to consider a DevOps strategy. So with that, I do want to close off on our last slide, which is probably the most important slide, a plug for our IBM Payment Center Canada. We have Andrew Higgins here, who leads the IBM Payment Center Canada. And with the Payment Center Canada, what we are offering is basically a SaaS platform. Everything we've talked about so far in terms of the architecture principles, we're kind of walking the walk and talking the talk. We're actually putting in place the same platform within IBM Payment Center Canada, which will offer in a SaaS fashion all the core payment capabilities we've talked about, whether it's your core payment processing or its capabilities within your payment processing, such as, for example, fraud and sanction screening. So whether you're looking for specific capabilities within the payment ecosystem, or you want to ship all those capabilities kind of to IPCC and say, well, IPCC is going to run it for me, I'm just going to consume payments in a utility model, then really that's what we are offering through IBM Payment Center Canada. Post this session, you can reach out to Andrew, and there are others here in the team from IPCC who can provide you more details. And we've also got in the booth much more elaboration of our hybrid cloud architecture, as well as DevOps strategy, API microservices. So we'll be happy to go into all the gory details. I didn't want to throw in all the technology jargon here, but we're happy to do so post the session. So with that, let me stop here. Are there any questions?
Yep. For companies, for smaller firms already in the cloud, never started with any on-prem processing, what can you say to them?
Can you be more specific about the question?
Yeah, a lot of these are about hybrid multi-cloud.
Yeah.
Hybrid evolution to the cloud. For those who are already in the cloud, Do you have any suggestions or guidelines for that kind of building?
Yeah, so I'll answer that. I think, Che, maybe you want to chime in as well. I think for those already in the cloud, when it comes to operating in the payment space, I think the biggest guidance that such companies would need in the risk and compliance space. And we have, I would say, competency from IBM perspective in that space that we can help those companies actually ensure that they are conforming to the right, have the right risk and compliance posture, conforming to the right regulatory, requirements. And of course, there are accelerators available as well for fintechs and for smaller companies to actually leverage a platform such as IPCC and to be able to plug in, for example, into back-end clearing and settlement engines or financial institutions. We are often working with fintechs and smaller companies who are operating typically on the payment initiation space but need assistance as far as the actual processing of the payments in the back end. So that's something that it would be relevant as well, I would think, to you. Che, do you want to add?
No, I think you covered it, and maybe we can talk afterwards. I'm not. Yeah, I guess depends on your institution, what type of businesses that you are doing on the cloud, as well as other businesses that you are expanding into, and so it'll depend a lot on.
The other thing I'd add is the 20022 Labs, which is being announced yesterday, today. That's one of those things you might want to look into. Because in addition to what we're offering here, there's many other IBM types out there that have many services you can use. There's IBM services, but 20022 Labs invites a lot of fintechs in. So you can actually use that as a playground to start innovating, collaborating, partnering, and leveraging what you've put on the cloud already. So that's a good way to actually monetize.
Thank you. There was a question over there.
Good morning. I have a question. You mentioned a lot about regulatory aspects of the moving to cloud. Mm-hmm. At the same time, the cloud is moving in leaps and bounds pretty much on maturity level. Mm. Are there any initiatives? Is anybody driving anything to review these regulatory aspects in the light of the developments in the cloud?
Yeah, so certainly, many cloud providers, including ourselves, we have certified our cloud environments to be in compliance with various regulations, SOC 1, SOC 2, PCI, HIPAA. So we do that too. The issue, I think, is really beyond that as well. It's about risk and compliance as well. It's about the appetite for risk from banks' perspective, and that I think will take some time for banks to feel comfortable actually placing their workloads outside of what they feel is their sphere of control. Because let's face it, a public cloud is a public cloud. Anybody can get to it. Versus a private cloud is locked down totally. So I think there's certainly, the short answer to the question, and we can discuss a little bit more after the session, is that I think many cloud vendors are building, I would say, purpose-built clouds as well to comply with regulatory requirements. Yeah. AWS is a great example. Rather, Amazon has done that, and we're doing that as well. But that said, I think because of the risk and compliance posture, banks are still conservative in the way they are approaching how they move specific workloads to the cloud, particularly core banking and payments workloads.
Yeah, I mean, just adding to that, so there are certain things that we are doing to meet certain requirements for government as well as for banking industry, especially regarding security issues. So one of the technology we just released is I think it's the first one that complies with FIPS, FIPS level 4. So that's some of the institutions require. So.
Okay.
During the journey to the payment cloud, so from architecture perspective, microservice architecture is mandatory or optional?
It's certainly not mandatory. In fact, we believe that microservices is not going to be fit for all type of applications anyways, because the utopian world of microservices is every microservices packages its own data. That works good for certain type of applications, particularly web scale applications, particularly applications that perhaps package reference data. When it comes to transactional data, one has to be really careful with that pattern. You can still have microservices from the perspective of the business logic, but you're not necessarily going to package data within that microservices because data is likely going to be shared. And with payment workloads, they tend to be very transactional in nature. You don't want a debit to happen and a credit to not happen, for example, to accounts. And so that's a simple example, but the reality is that payments workloads need high amount of transactional semantics, the so-called asset semantics, right? Atomicity, consistency, integrity, durability. So you need those semantics, and therefore the way we see it is that there are certain workloads that will be well suited for that nirvana vision of microservices. There are going to be other that are suited to the vision of microservices more as an integration service, a business function service, which actually doesn't actually package data. It might actually share data in the sense that you have a set of microservices that are actually operating on the same piece of data rather than islands of data. We know that data tends to be relational, or even in the case of key value pairs, there is relationships between data. So when you go with that pure microservices approach for what are transactional workloads, it can cause challenges.
Yeah. In particular, in the microservices world, if you take that literally, it's going to guarantee what's called eventual consistency. In a transactional world, when you're depositing and debiting, you don't want eventual consistency. You want strong consistency. And that's why, I think the technology will evolve, but there are certain things that just may not make sense, at least today, if you're taking the microservices architecture literally. So.
Okay, all right.
Just one last thing. There is a report that was just published by IDC. It's called 10 Hard Realities and Opportunities in Payment Modernization. So we have a few paper copies here, and if you like electronic copies, you can stop down at the IBM booth and pick up or get the code for the electronic copies. So thank you very much.
Okay, thank you. Bye-bye.